This is 3 worked examples from the book How to Think Logically by C. and Nuccatelli. This is page 352. I plan to do 9, 14, and 20. Let's start with number 9. Some candidates for public office are not persons who are well known. After all, that sounds like premises coming up. Some citizens who are listed on the ballot are not persons who are well known, and all citizens who are listed on the ballot are candidates for public office. I think the first sentence is the conclusion, so it looks to me like the conclusion is some candidates for public office are not persons who are well known. Here's a premise. Some citizens who are listed on the ballot, let's use L for listed on the ballot. And I used C for candidates for public office, and then persons who are well known, that was P. Okay, so some citizens who are listed on the ballot are not persons who are well known, and all citizens who are listed on the ballot are candidates for public office. So I need 3 circles. Some L are not P. If this is L and P and C, then I need an X inside L but not in P. Here's inside L and outside of P, those 2 regions, so I have to put the X on the line between them. All LRC is pushing L down into C. That moves my X. Before I wasn't sure if it went up or down. Now I know it goes down. I can say 3 things about that X. It's in L, it's in C, but it's not in P. My conclusion says that some things are C but not P. That X is in C and it's not in P, so that's on the diagram, and this argument is valid. Okay, now we'll do 14. All people who ride bicycles in rush hour traffic are courageous people. 4, premise coming up, some courageous people are professors who are not tenured members of the faculty. So there's the first premise. Some courageous people are professors who are not tenured members of the faculty. Second premise, no professors who are not tenured members of the faculty are people who ride bicycles in rush hour traffic. Now remember, the conclusion was this first sentence. All people who ride bicycles in rush hour traffic are courageous people. One thing to note is that this not right here is buried inside the predicate. I can't take it out. I shouldn't say not professors who are tenured members of the faculty. That means something different than professors who are not tenured members of the faculty. Okay, I need 3 circles. C, P, and B. Some C or P, that's an X in C and in P. So here are 2 regions that are in both C and P. I put the X on the line between them. No P or B is shading the overlap between P and B. There it is. Now that X moves up. Before I didn't know if it went in the middle or up here, so I put it on the line. But since I know this region is empty, I know the X moves up. Now I can say 3 things about that X. I know it's C, I know it's P, and I know it's not B. So if the conclusion said some P are not B, then I would know that argument to be valid. Instead, the conclusion says all B are C. That would be pushing the B into the C. If that region were shaded in right there, I'd say it's valid. But that region's not shaded in, so this argument is invalid. Okay, now let's do number 20. Some senators who are not opponents of foreign aid are friends of the president, but all friends of the president are influential people who are well informed about world events. Hence, here's a conclusion coming up. Some senators who are not opponents of foreign aid are influential people who are well informed about world events. Don't let all those words confuse you. Senators who are not opponents of foreign aid are, there's the verb, we split there, influential people who are well informed about world events. That's another category. So the conclusion is, some senators are influential people. Okay, first premise, some senators who are not opponents of foreign aid, I'm calling that S. Some S are friends of the president. but all friends of the president are influential people who are well informed about world events. I'm calling that I. We need our 3 circles. S, F, I. Some S or F, that would be an X in the overlap between S and F. All F or I is pushing the F's down into the I's. Now we move that X. That X is on the line. We didn't know if it went up or down, and now we know it goes down in the middle. You can tell me 3 things about that middle region. It's in S, it's in I, and it's in F. So if our conclusion says any combination of those 2 things exists, then we'll know our conclusion must be true. It says some S are I, so we're looking for an X inside of S and inside of I, and we already decided that that X fits the bill, so this argument is valid.